Morning, this is Ms. Billerbeck, and we are going to talk about 7.1, adding and subtracting polynomials. So let's start with the monomial. So mono means one, nomial means number. So a monomial is a real number, a variable, or a product of a real number and one or more variables with a whole number exponents. Okay, this whole number exponents means that there's no fractional exponents. So we shouldn't see any fractions right here as exponents. Okay, and whole number means 0 is included. Okay, one more thing about whole numbers is there's no negatives in the exponents. Okay, so that's pretty important. This is very specific number family. Whole numbers 0, 1, 2, 3, 4, 5, 6, etc. Okay, so if we have 17x cubed, that's a monomial. 1/2 a squared b to the 6, that's a monomial. It's okay to have a half for a coefficient. It's okay to have a negative number as long as the negative's not in the exponent. So negative 275 is a monomial. It's also a constant. M to the 0, that's a monomial, okay? So let's talk about the degrees of a monomial. So the degree of a monomial is the sum of the exponents of the variables of a monomial. So if I have 578x squared, the degree is 2 because that's the sum of the exponents. If I have 3/65 a to the 7th b to the 8th, 7 plus 8 equals 15, so the degree is 15. If I have negative 3x to the 0, the degree is 0. If I just have a plain number 27 without that 27x to the 0, it still has a degree of 0 because 27 is the same thing as 27x to the 0, because if we remember, x to the 0 equals 1. So 1 times 27 is 27. So constants still have a degree of 0. So poly means many. So nomial number, so many numbers. So a polynomial is a monomial or the sum or difference of two or more monomial terms. Okay, the degree of a polynomial is the greatest degree of any term of the polynomial. So if I have negative 7x squared y cubed plus 5xy squared plus 2x minus 10, it's a 5th degree polynomial because this is 2 plus 3, which is 5. This one is just 1 plus 2, so that's a 3rd degree. And this is a 1st degree because we remember we don't write those exponents. So that's how we would determine those polynomials and their degree. Let me erase this. Okay, so we don't usually write the 1, but it is there. All right, so let's take a look at a few of the ways that we name polynomials. All right, so if I have a polynomial that's 7, remember that's the same thing as 7x to 0, so it has a degree of 0. It's considered a constant because it's unchanging. It's always going to be 7, no matter what variable x is, because if it's 3 to the 0, it's 1. If it's 5 to the 0, it's 1. And there's only one term. So the number of terms is 1. So it's a monomial. 3x has a 1 up here, which we don't write. So it's a degree of 1. It's considered a linear polynomial. And it has one term. So again, it's a monomial. If I have x minus 27, that again has a degree of 1 because x without an exponent, it's x to the 1. So the degree is 1. It again is linear when it's a degree of 1. And it has two terms, 1, 2. So we have two terms and it's called a binomial. Now we ride bicycles, which have two wheels. So bi means two and nomial number. So two numbers, 1, 2. If we look at 5x squared minus x plus 4, the highest degree monomial of the polynomial is at 5x squared. So it has a degree of 2. And it's considered quadratic. That's a fancy word, but that's a quadratic equation, which we are going to be studying. So the number of terms, 1, 2, 3. So we have 3 terms. This is called a trinomial. Like a tricycle has 3 wheels. Tri means 3 numbers. So trinomial is 3 numbers. So negative 6x y squared minus xy plus 1. Well, that's a third degree polynomial because we have x to the 1 plus y2. So 1 plus 2 is 3. And it's considered a cubic if it's a third degree polynomial. We happen to have 1, 2, 3 terms. So that's 3, and it's a trinomial. As soon as we go over 3 terms, we change over to polynomial. So 11x squared y squared plus y squared plus x squared minus 7. This one, if we add up the exponents on the largest term, we have x squared y squared. So 2 plus 2 is 4. So we also don't have any fancy name like constant, linear, quadratic, cubic. It's the 4th degree. So now after this, we do 5th degree, 6th degree, 7th degree. Okay, so it's the 4th degree. And we have 1, 2, 3, 4 terms. Okay, so this is when polynomial starts after the trinomials. Okay. All right, so the standard form of a polynomial is the form of a polynomial in which the terms are written in descending order according to their degree. Okay, so we write from the highest degree to the lowest degree. So if we write, so for example 1, we're going to write these polynomials in standard form. So first we look at the terms and we see this is a 0 degree term. This is a 3rd degree term, and this is a 2nd degree term. So we're going to write this as negative 3x cubed plus 6x squared plus 7. So we put the highest degree first, the second highest next, and the last term goes here. So we have to be very careful about where these minus and pluses go. So if we look at this, this is a 1st degree, that's a 0 degree, and that's a 2nd degree monomial term in a polynomial. So we're going to put this one first, negative 8y squared plus 2y minus 3. So we have negative 8y squared plus 2y minus 3. So that would be standard form for both of these polynomials. For this example, we're going to try combining like terms. So we want to combine the like terms and write each expression in standard form. So I have 4x squared. And I notice I have another x squared here. So let's move that over here so it's next to it. And then I have minus 3x here and plus 3x there. So I moved the like terms next to each other. So this one really has a 1 right in front of it. So 4x squared minus 1x squared is 3x squared. And minus 3x plus 3x, well, that's just, this is equal to 0. So our answer is just 3x squared. All right, for this one, we see, okay, I have 7y cubed, and then I have a 5y cubed. So let's put that one next to it. Then I have minus 3y and minus 2y. So I've got that one, I've got that one, I've got that one, I've got that one, and then I have plus 7. So this equals 12y cubed, and this is minus, and I have same sign sum, so 3 plus 2 is 5, and they're both negative, so it's 5y, and then plus 7. So my highest degree is first. So third degree, first degree, 0 degree. So this is how I'd write the standard form of this polynomial after I've combined like terms. So let's take a look at a little definition here. So the closure property of mathematics states that a set of numbers, counting, whole, integers, rational, etc., is closed under an operation when the result of the operation is also part of the same set of numbers. So if I add a whole number to a whole number, I get a whole number. So that's a closed property. So 2 plus 2 equals 4. All of those numbers are actually counting numbers or natural numbers. So that would be a closed property. Well, polynomials are closed under addition and subtraction because the result of these operations is another polynomial. All right, so let's take a look at this one. So we are going to simplify and write the answer in standard form. So we have to be careful with parentheses if this is not a plus. But when it is a plus, these parentheses really don't do anything except associate those binomials, that binomial with this binomial. So we're adding two different binomials. So let's start putting them together. So there isn't an x squared term except for 3x squared. We have plus 2x, and then we have plus a minus x, and then plus 9. So the only two terms that are alike are the 2x and the minus x, and that's really a minus 1x. So 2 minus 1 is just 1x. So we have 3x squared plus 1x, and then plus 9. But we don't really write the 1x. So we'd write 3x squared plus x, because we know that the coefficient is 1, and then plus 9. So that's how we would write that. Now let's look at this. There is no other x squared term, so we have minus 2x squared. We have plus 5x, Here I have a 3x, so I'm going to add 3x here. Then I have minus 7, and then I have a plus 7. So I have these terms that I can combine and these terms I can combine. So 5x plus 3x is 8x, and negative 7 plus 7 is just 0. And then this just comes down to x squared. So my final polynomial in standard form would look like this. Negative 2x squared plus 8x, and then there's nothing to add here. So that's it. All right, now we have to be careful with the parentheses because this is a minus sign as opposed to a plus sign. So we're going to simplify and write each answer in standard form. All right, first of all, we have to deal with this negative here. So what that is it's a distribution problem. So we have 3x squared plus 4x plus 2. Then I have minus, and it's a negative 1 times that negative x plus 4. So I'm going to take that negative 1 and I'm going to distribute it to both of those. So I have 3x squared plus 4x plus 2, then a minus negative x makes a positive x. A minus negative 1 times 4 gives me a negative 4. So now I've dealt with that minus sign right here. And you must be very careful when there is a negative sign here to get that negative transferred to the second term. That is the number one mistake. So now we can start combining like terms. So we have 3x squared. There's no other x squared. We have plus 4x. Let's move this x near the 4x. Plus 2 minus 4. So I see, if I put the 1 right there, I have a 5x right here, and this is a negative 5. So my answer would be 3x squared plus 5x, and 2 minus 7 is negative 5. And that's my standard form when I subtract a trinomial or subtract a binomial from a trinomial. Okay, so now I'm going to subtract a binomial from a binomial. So I'm going to take this negative and distribute it to both of those. So I have negative 5x minus 6, and I have negative times 4x squared, so minus 4x squared, and a negative times that 6, negative 1 times that 6, gives me negative 6. So I rearrange this, negative 4x squared. I have no other x squared terms. I have minus 5x. I have a minus 6 and a minus 6. So I can combine the two constants for my final equation and get negative 4x squared minus 5x and then minus 12. And that's how we do it when we're adding polynomials. All right, let's look at a real life problem. Okay, so given the solar farm area represented, what expression models the difference between the large and the small solar panels? So if I have solar panels and the length of 32x on this side and x plus 12 on this side, the area of those solar panels is 32x squared plus 384x. Okay, if I have 33x squared plus 275x, well, that gives me a height of 11x, or a width of 11x, and a length of 3x plus 25. So when I multiply length times width, I get the area here. And the same with the small solar panels. So if I don't know what x is, and I've got my length as 4x, and then our width as 4x, and my length is x plus 6. When I multiply length times width, I get 4x squared plus 24x. So now we need to know, well, what's the difference in area of between the big and the small? So we can set this up 3x squared plus 384x, and then subtract 4x squared plus 24x from that. Let's put this right under there so we don't get confused. Okay, so we have to remember we're subtracting both terms. So 384 minus 24, so we have an x. 4 minus 4 is 0. 8 minus 2 is 6, and we have 3. So 360x plus, and then this one, I had 4x squared, and that, oops, I forgot something. That's a 32x squared. That makes a big difference. Okay, so I've got x squared here, and I'm going to carry there. So 12 minus 4 is 8, and 2 minus nothing is just 2. So the solution then, the difference between the large solar panel and the small solar panel will now be 28x squared plus 360. So there you have it. Have a wonderful day. Bye-bye.